Good afternoon, everybody. My name's Alex Eames, and I run a website called RasPiTV. There's my logo on the t-shirt, nice small logo. Could we have a quick show of hands? Put up your hand, please, if you've not heard of RasPiTV. Okay, so there's a few. Okay, well, you have now. It's a fairly popular site. I blog about things to do with the Raspberry Pi. I've got several different kinds of posts. Well, I started out, basically, when I first started using the Pi, I didn't know a great deal about Linux, and I found a lot of things quite difficult to find information about. So I thought, actually, there needs to be a record somewhere of how to do some of the basic things. So my focus is really, for those kinds of posts, is on complete instructions that work first time, and I do try quite hard to keep that up to date when things change. As time went by, I started blogging about things I'm doing now. So it's when the Gurt board came out, I got really quite into hardware stuff, as you can see on the screen there. And so quite often I blog about things I'm doing right now, like when the camera module came out, when the Pi Hub came out. It's like, yeah, this is now. So those are a little bit newsy. I also teach in my son's school as a volunteer. There's a very strong ethos of parent involvement in the school that my son goes to. So for the last 5 years I've been teaching ICT to Year 5s on a Wednesday afternoon. And this term they've asked me to do Year 6s as well. So one year I had a fairly unfortunate experience. It was the first year that I was doing it, and I thought, right, a long time before Pi came out, and I wanted to do a demo on data logging, because I had a nice data logger that plugged in by USB to a laptop, and I had this really nice demo where they could turn a dial and make a propeller go on a remote control airplane motor, and see what the current was, and you could see it on the screen and everything. And I took it into the class, and it was great. I plugged it in, and it didn't work. And I was a fairly inexperienced teacher. It was my first year doing it, and I just had one of those experiences where not only have you got a class full of kids in front of you giggling because your demo doesn't work, so you feel like a big fat twit, but you've also got to completely replan the whole lesson with zero notice. Now, if you've been to teacher training college and done all of that stuff, then that's not a problem, because you've got something in your pocket all the time about a reserve plan. But I wasn't, so that was just so horrible. And I just thought, when the Pi came out, I thought, wouldn't it be really nice if there was a way that you could demonstrate some of the cool things that you can do with the Raspberry Pi in a sort of a more plug-and-play way, without lots and lots of wiring. Now, this is a prototype I'm going to show you. It does have quite a few wires, and that looks a bit ugly, but the idea is that it should be relatively easy to do interesting things with the Raspberry Pi without actually having to spend weeks and weeks and weeks learning about all the technical side of it, which I have, but because I'm self-employed and I run my own business, I get to choose how I spend my time. Most full-time teachers actually don't have the time to learn all this extra stuff. So I think it needs to be a little bit more plug and play. For example, here, you can't see it that very well, but here I've got a temperature sensor plugged in. My goal with this board that I've developed, which is called RasPio, which is Raspberry Pi I/O, which is input-output, is that you should be able to have a temperature sensor or something like that, and just plug it in, type a command on the computer, and read the temperature. And the idea behind that is that you should be able to see that in class, and my hope is that it would help people to actually be encouraged to actually then say, well, that was easy. But let's have a look at the code and see how it works. Let's see if we can tweak it. Let's see, to try and encourage people to get under the hood. So I've got a little bit ahead of myself, so what I'm going to do is I'm going to just have a very quick walk around the hardware. So please don't go to sleep, because there's going to be some audience participation stuff in a few minutes. where I'm going to get some of the children, hopefully, to come down and actually do stuff. That's very risky, I know, but hopefully it'll be all right. Okay, so here, basically what we've got is it plugs into the main Raspberry Pi header, which is here, by a ribbon cable. The final board will push straight onto the Pi. So we've got protection for the input and the output ports, with using resistors and Zener diodes. We've got a chip here which protects the outputs and enables you to be able to switch things like relays, and you can also use it to run stepper motors and things like that. But I've got some demos with that, but I'm not going to show you that because I wanted to maximise audience participation today. Here we've got, can you see what I've got? Yeah. Here we've got a chip which is an 8-channel analog to digital converter, which enables you to read things like temperature sensors and light sensors and other things. Here we've got 3 buttons and a potentiometer, which you can use for controlling things. And this chip here, which probably won't make it to the final edition, is a digital to analog converter, which, as the person who's working with me on this said to me, what do you put that on there for? And if you can find a use for it, we'll include it. And I thought, well, actually, you know what? I put it on there just because I could, so probably it won't make it to the final edition. The real truth is I put it on there because I wrote the driver for it. And I'm pretty proud of that. Pretty surprised it worked, actually, but there you go. Okay, so that's the walk around of the hardware. There's also some nice bright blue LEDs that are on the output ports, which you can use for various things. That you could just use them to indicate. We'll be using them to indicate later on when buttons are pressed and things like that. So, okay. Yeah, that's a quick walk around the hardware. Oh yeah, a scary look underneath. This is a prototype, but I've got to show you this. You see that? That took me about a week to make. I don't do stuff like that anymore. I do it straight on PCB now because I've figured out how to do it. But all right, so that's a scary look underneath. Right, now it's on to the demos. I need to switch over to the other screen. How do I do that? How do I make this thing come alive? Do I have to pick it up? It seems to be off.
Just touch it.
Oh, it's that easy. Okay, VGA2. Oh. Okay, excellent. You can see the same as I can. All right, so the first program I've got is just a quick test of the analog to digital converter. So over here I've got a temperature sensor in the first position, another temperature sensor in the 4th position, a light sensor in the 7th position. And the 8th position is controlled by this potentiometer. So when I press enter, hopefully you'll get 8 readouts of each of the positions. So telling us 2 temperature readouts on number 1. Is this the pointer? Number 1. Has it died? Oh no, demonstration theory. Okay.
You'll have a backup plan.
I might have to reboot.
You've got enough stuff at the top.
Frustrating, but I may just have to quickly reboot the Pi. What does that mean? You guys are quite funny people compared to the classmate kids.
You should see them tweeting.
Yeah, yeah.
Rebooting the play. Where's he got the compressing notes message from?
Exactly.
I don't know. Oh, it's queuing you.
Hurrah!
Oh, it's not the same anyway, it's deadly. It's definitely just the same. Maybe it could be on
Okay. Okay, so we've got 2 readings of temperature. We did have, that one's crashed again.
Last minute
Oh
changes.
no, it used to work, honest. Alright, I'll have to try one of the others. I don't know what's gone wrong with that. Maybe that's what it was. Okay. The SD card holds up. Right, well, forget about the ABC, maybe something to do with the SPR. Hopefully they'll put some work fine. I do apologise. Right, next up we're going to have a look at the inputs to check that the buttons that I've connected, I've got a couple of button boards here connected, and we'll check that those are working. They don't involve the SPI bits and the ADC, so hopefully that will be working. And if it is, I'm going to require a couple of volunteers. So could I have a couple of children to volunteer? Okay, you were first up at the back. You two guys. Yeah, would you like to come down, please? And we'll see if we can make this work. Okay, brilliant. Okay, right, I'm going to give you each one of these. Number 1, there you go, you're David and Daniel. Okay, so you've got 3 buttons on these boards, 1, 2 and 3. David, can you press button number 1 please and see if it works? Okay, great. Number 2? Number 3? Fantastic. Daniel, can you press your button number 1 please? That's the top one. Okay, number 2? Number 3? Okay, can you both press all 3 buttons at once? Can you do that? You might need to use 2 hands. Yeah, brilliant. It's working. Fantastic. Thank you very much indeed. I got some prizes. There's a little Raspberry Pi nylon badge. Thank you very much. Well done, guys. Okay, so the buttons are working. That means hopefully the next one will work too. Which is going to be a quiz. All right. Oh, I think. Whoops. That's me trying to be fancy and type fast, isn't it? All right, so another young person, please, volunteer. Okay, brilliant. Would you like to come down? Are you good at maths? Do you like maths? Yeah. Good. Don't worry, it should be fairly easy. Just give you the first controller. Oh dear. Unclipped my microphone. Okay, just if you'd like to hold that. That's button number 1 at the top, that's button number 2, and that's button number 3. How do you say your name? Joby Dave. Okay, brilliant. Okay, so what you're going to do is you'll see on the screen up there, there'll be 3 maths questions that I hope you'll be able to answer. So if you think the answer's the first one, then you press button number 1. If you think it's the second one, you press button number 2. If you think it's the third one, press button number 3. Well done. Okay, second question, 3 minus 2. Which one do you think it is? Well done. And the last one, 3 times 3. So what are 3 threes? You know that one? Excellent. You got 3 correct and you took 18 seconds. Fantastic. Well done. Let's see if I can... Let's see if I can do better. So button 1, change player. I'm going to have a go now. I think I use the right computer. Alex C. Who's he? Alright, I'm just going to do it as quick as I can. Oh, I just pressed the middle button 3 times and I got 1 right. So it was faster than you got. Well done, thank you very much. Okay, let's just run that program one more time. Let's do the RasPiTV quiz because that's a bit fun. I'm just going to throw this out to the audience. Okay, the Raspberry Pi has hacked it to the programming language Python. False, true, or pass? What do we think?
True.
True.
Okay, true, A2. Okay, the Rev2 Pi board comes with a P6 header. It's standard. True, false, pass?
True.
Missing.
False.
False. P6.
False. Shorting the P6 header resets the Pi. True, false, pass?
That's ambiguous. P6 header's got
True. Okay, which of the following does not license manufacture the Raspberry Pi? Mod, MyPi, Farnell, RS. Okay, good. How many Raspberry Pis have been sold? 1.7 is correct. RasPiTV blog will hit 1 million page views next week. True, false? It's true. The Raspberry Pi has 48 GPU cores. False, true, yep. Pi Hub can power 4 Raspberry Pis at once. True, false, pass. Okay. The Pi camera module can shoot 1080p 30 video. True. Who knows? How many pins on the main P1 GPIO header? 26. Yeah. Okay. Okay, button 1, change player. Let's just... I've got funny names today. Still got half of them right. I'm much quicker than you are. Okay, so this is just an example of something you can do with a little extra add-on buttons using inputs and have quiz. Can you imagine? It'd be nice, good fun to actually do maths tests like that in class, wouldn't it?
Yeah.
Rather than having to write them down. You could database all the results and everything. I just think that would be excellent, really. And I've got one more. How am I doing for time, Mike? I've got one more demo that I'm going to need some volunteers for.
You're doing fine.
How many minutes?
Got 13.
Oh, brilliant. Okay, excellent. Can I have some volunteers who haven't been down yet? This is a game.
Yeah, it's down there at front.
Okay, there's one.
Down there?
And another. There's possibly going to be time for more than one to play this, but if we stop this, maybe I'll have a quick show you the US breakdown quickly as well. If you can make your way down. 2 volunteers. Right, this game is going to be a reflex game. I find in my classes, if the children think they're playing games, I mean, okay, this won't have that much educational value, but if the children think they're playing games, they learn stuff without support for them. So that's always one of my aims. You are Albert, okay? Put your name in, and you are Ben. Excellent. All right. So what we've got here is you get one of these each. Now these button boards have got a little red LED on them as well. So with this game, what happens is, in the first round, you have to do this 10 times. In the first round, player 1 presses a button, and then the computer, the Raspberry Pi, will wait a random period of time, up to 3 seconds. It could be 0.1, it could be 3. And then it will light both of your LEDs at the same time. It will also light 2 LEDs on here, big bright blue ones, which the audience might be able to see. But if I move it, it probably won't work. after that. So basically, when the light comes on, you want to hit one of the buttons as quickly as you can. All right, and then when it's round 2, it'll be you who decides when to start. So it alternates. Okay, so you get 5 goes at each, and at the end, it will give you your statistics. Okay, so Albert, if you'd like to press any button, you both wait for the red light to come on. Okay, brilliant. Now Ben, it's your turn to press first. Okay, keep going, Albert. Okay. After 3 goes, it starts averaging. Obviously, when you've only had 1 or 2, it can't really average. That's very effective. Oh, okay. It will actually, when it comes to the final statistics, it will dump your best and worst scores and then average the rest. So it doesn't matter if you have a boo-boo. Albert, whenever you're ready. Okay. Okay, so that's finished. Fastest reaction time, 0.17. That's very close. You're very close. Evenly matched. Does it show? I made the font big especially for this, so you can't actually normally see more of that. Fastest reaction time overall. Reaction time. Who got the fastest then? Ben. 0.17. Average minus extremes, then also slightly ahead. Okay, if you'd like to press button 1, play again. That's right, the top one. Okay, brilliant. Can I have 2 more people? Let's give you both a reward. Can I have 2 more fast finger button people? Okay, come down then. All right, if none of the children want to do it, well, we can take an adult. Come on then. All right, off you come. Off you go. All right, will we play well? Okay. Oh, you've been down already. Come on then. It's my favourite volunteer. Joby. All right. There you go. And what was your name? Alex. Good name. He's why we're here. Okay, so if you'd like to press a button, and then when the red light comes, you both press any button as fast as you can. Press it a bit harder. Brilliant. Okay, now it's your turn, Alex, to press a button. And when the red light comes on, that's it. Okay, it chucks away your worst score, so don't worry. Okay, keep going. Ah, did you see that? Somebody pressed the button out of turn and tells you that you're cheating. So basically, Alex, you need to press again to start that. Very, very, very occasionally it will. I have managed to get it so it will give me a dead heat, but it's quite hard to get because it has a resolution to about 10,000 per second. So. Okay, keep going. Okay. Press button, that's it. Okay, Alex, you press. Alex. Okay, brilliant. Can one of you press button 3? Because I'm just going to show you what happens right at the end. Right at the end, it gives you an overall statistics for everybody's scores. See it? So it seems to have missed one person off. Never mind. Look at the software. Okay, so who one out of you? Alex was just a little bit faster. 0.21 overall. Sorry, 0.19 overall. Jody gave 0.21. Quickest overall time. 0.17. That's really fast. Okay, brilliant. That's a little reward for you. Volunteers, thank you very much. I got mine? Well, there's a lot of possibilities that you can do with a board like this. When the analog to digital converter is working, you can do weather stations and all sorts of interesting and fun projects. There, what I was going to get somebody to do, I was going to get somebody to heat one of the temperature sensors and put a pen over the light sensor, and basically you'd see that the voltage drops significantly when the light sensor is covered. But unfortunately, that one wasn't going to work. So I'm going to just spend a couple of minutes showing you the RasPi camcorder, just for fun. When the Raspberry Pi camera came out, I thought it would be fun to make one into a camcorder. So here we've got a Syntec case with the Raspberry Pi camera stuck to the front with hot glue. Inside I've got a small little Bluetooth module which enables me to log into it. Enables me to log into it using my Nexus or telephone, smartphone, to be able to make it do things when I'm away from my home network. There's also a little voltage regulator in there that enables it to be powered off a battery. It can take pretty much any battery up to about 35 volts. But is there an HDMI? Have you used an HDMI on yours, Ryan?
Yeah.
What number was that? Let's just connect. What happens is when I power it up, it should just boot straight into camcorder mode. And then when I press the button, it will start recording, and you should be able to see what it's recording. The RasPi hopefully will become a product, and hopefully should be out a little later in the year. But as you can see, there's more development work that needs to be done on it. But that's the first time that demo has ever failed on me, so that's a shame. Okay, camcorder's booted and waiting for a button press. It's a bit dark in here, but you can see it is. Shine it on something a bit brighter. You can see it's working. The low light performance of the camera isn't fantastic, but then I wouldn't normally use it in circumstances like this. Okay, so what we've got here on the back, you see you've got the LED on the front of the Pi camera that tells you when it's recording. I also put one on the back, because when you're actually using a camcorder, you don't necessarily want to look around and see whether it's recording or not. So we've also got buttons here. There's a blue button here which works for switching it on and making it record. The black button will stop it recording. And then on the screen it tells you, if you've got a screen plugged in, which you don't have to have, it tells you how much space you've got left on your SD card. So,
Alex, if you set it to night setting, it will be brighter. That's better.
it probably would. I'm afraid
Yeah.
I haven't got that built into my software yet.
Okay.
But yeah, I've actually got the software for this. If you wanted to make one, I've got the software for it on GitHub under RasPiTV. It's all one word without a dot, I think in lowercase. So that's the Pi camcorder. You can also get it to stream video to a tablet, a Nexus, or your computer if you're on it. It's not this. I haven't got it. This isn't network connected. But you can get it to stream video via Wi-Fi, and you can also use it to take stills, upload for Dropbox, so you can link it with your Dropbox account and upload photos as you take them. And yeah, you can log in with the Nexus or your phone as well to control it. Was that the finish flag? Okay, brilliant. So that's me done. Most of it worked. Thanks very much.